All right. So below two planets with gravitational fields, which planet has the stronger gravitational field?
A.
Why?
The lines are close.
Sorry?
The space between the lines are big.
Space between the lines, and there's more of them, right? The planets are about the same size, so that's how you're able to tell that the gravitational field strength on A is greater than that of B. Is it possible to tell which planet has a greater mass?
Yeah.
How?
Because A is on multiple lines.
Yeah. Strong. Gravity is based largely on the mass of the planet. So the more mass it has, the stronger its gravitational field. Jupiter has a very, very strong gravitational field when you compare it to the other planets because it's the biggest. The Sun, a lot more mass, a lot stronger field. If an object is placed at point K, which is exactly between the two planets, what would happen to K?
Accelerate towards.
Oh, I like Katie's answer a little better. What did you say?
It would accelerate towards A.
It will accelerate towards A. Not just move towards A, not just move towards A with a constant velocity. It will accelerate because it will always have a net force being applied to it from A. Therefore, its velocity will never be constant. It will always be accelerating. A 400 kilogram mass is placed at point V, right over here. How strong is the field at that point if it weighs 400 newtons?
1 Newton per kilogram.
1 Newton per kilogram. How'd you figure that out, Helen?
400 Newtons over 400.
400 newtons over 400 kilograms. And that's just using a variation of F equals mg, right? And you're all going to get those units right. 1 Newton per kilogram. And if a person is standing on planet B, is still in planet A's gravitational field, why does that person not move towards A? Yeah. B still has its own field. B is still, even though the person's standing on the surface and is not accelerating towards B, B is exerting a force on that person and therefore keeping that person on that planet. So even though A is pulling on that person a little bit as well, it's not enough to get them off of B. Michelle?
Another answer would be that the lines are closer together in position. Yeah, I haven't continued.
Well, we didn't give you a position. We just said that he's over there. But yes, actually, you're right, actually, because the lines up for B, if we were to extend the lines of A out, and we put a person right here, the lines for B at that point are closer together than the lines for A. So you're absolutely right. The field of B is stronger at that point. Good. All right, so here we have a magnetic field. So the compasses on the diagram have a shaded side. What pole on the compass is the shaded side?
North.
Yeah, it's the North Pole because it's being repelled by the North Pole of the magnet over here. So it's repelled by that, and they're attracted to the South Pole. So on all these little compasses, the shaded or the red part is the North Pole. If you placed a compass directly in the middle of the magnet above it, in which direction would it point? It would point towards the south. So if we placed it right there above the magnet, you'd have the shaded side pointing that way, and the non-shaded side would look like that.
If we would have put east, then I guess would be the last
Sorry?
one. Put east, be the last one.
Oh, not if you did this. If you put a compass direction like that and tell me that that's east, then sure, you can do that. That's fine. Looking at points X and Y, what direction would a compass point at each of those locations? So for X, let's draw a little compass.
Are they the same?
So here's my compass. So I place it at X. Which way is it going to point?
Well, it would follow the field lines.
So
There.
there. And we place the other one at Y. It's going to follow the field lines. So the shaded side away from north towards south by following the field lines. Some students, when they place it here, they think, oh, well, it's got to point, it's going to go towards south. So they'll try and take this one and they'll try and say, okay, well, it needs to go like that because it needs to point towards south. But right now, the field is stronger. The field lines tell you that it's being directed away from the North Pole, and it's because it's stronger. The North Pole is stronger at this point than the South Pole as far as the overall field is concerned. Janaea? North.
Oh.
Yeah, it's the north side of the compass because they're all pointing away from this North Pole and they're all pointing towards the South Pole. Yeah, where would the field be stronger? Sorry, that's the second part of this question. It would be stronger at X. And again, I did it on purpose. I put it right beside the line here. I really want you girls to get that even though it's right beside the line, it's the distance between the lines. So the distance from here to here is greater than the distance from here to there. Below is a point field generator which repels electrons. Draw proper field lines around it. So if it repels electrons, well, field lines should go towards it. And that's because if it repels electrons, electrons are negative, so a positive charge would be attracted. So the field lines should go in. Which would also mean that this field generator is what? Positive or negative?
Negative.
Yeah, it has a negative charge. If you placed a proton at point $sign. Oh no, sorry, we forgot question one. An electron placed at point $sign experiences 6,000 newtons of force. What is the strength of the field at that point?
0.75.